Hello students, welcome to KENE'S Educare, a group of KENE solutions. This is part 9 of lesson number 8, motion. So as you all know that in part 8 we started with the equation part where we saw that there are three different equations which can be calculated and graphically represented as well in the form of graphically, as well as we can represent that in the form of equation, right? One was with respect to velocity, acceleration and speed. So we have the three formulas which we came up with in the last class, right? And even we discussed on two different activities where I told you to plot the graph, and I hope everyone was able to interpret the data that was provided and draw the graph properly. Okay, and even we have discussed like so many parts in the lesson. Like motion has been the lengthiest lesson till now, I guess, having more parts, because like over here in this part we have many information which has been provided, and I am stretching it so that you all are understanding it and you're applying it to the real life example. That is what is very important, right? So we will be doing the equation part. I will be explaining you all the three equations today, and if possible I might end the lesson in this part itself, or I might require one more part because we have uniform motion and like uniform circular motion to discuss as well, right? And along with uniform circular motion we have summary and then 10 different questions. So maybe I can like have one more part, because if I do all the things in one part it will be like very much hectic for you to grab all the concepts together. Okay, so keeping all this thing in mind, we will like do all the three four equations that we have, and we will revise everything that we have studied so far. Now make sure whenever you are revising it, you are revising it properly, and you don't have to like sit with your book after this for studying motion. You have to revise it as such. Okay, because I provide you with sufficient time to revise, and you should develop the same habit so that you are helping others, you're helping yourself as well. Because since every part we are revising it now, many of you might even write the answers on your own. Many of you might be even able to solve the example, because there are so many examples that we have like seen with respect to different formulas, right? So everything is important. Okay, so now I want each one of you to please start revising, because we have started the lesson by discussing on describing motion in detail and different examples with respect to it, right? So now I want you all to please start revising whatever you have in your book, because I will be sharing the slides as well. So you can just correlate whatever you have written what is sufficient or not, or you need to have some additional points added. This all things you need to keep in mind. And activity you have written already, right? The observation, explanation, and conclusion. So when I'm sharing my screen for the activity one, how you are going to revise it, you have to explain it to yourself. Like you have to explain it to yourself about like the explanation part for that activity, observation for that activity, and lastly the conclusion part as well. Okay, so now I want you all to please start revising whatever we have discussed so far, so that we can start with the equation part as well today. So like once you're done with it, I'm going to show you the slide as I said. So everyone please be quick with your revision part. So we have started the lesson by discussing on describing motion in detail along with the example, right? So I just want you all to please go through the slide quickly, everyone. After this, we discussed on motion along a straight line. So I want you all to please go through it properly, quickly. After this, we discussed on this activity 8.1. So I want you all to please go through it quickly. After this activity 8.1, we even had activity 8.2. So I just want you all to please go through it quickly. After this activity 8.2, we discussed on uniform and non-uniform motion. So over here we have information on uniform motion. So I just want you all to please go through this quickly as well. After this we discussed on non-uniform motion as well. So I want you all to please go through it. Now here, along with non-uniform motion, we even have information on rectilinear motion, because when it comes to uniform motion, we do not have rectilinear motion over there, right? So if the motion is not consistent, and that will be in case of rectilinear motion itself. So if motion is not consistent, the acceleration of the body will be non-zero. And the example given over here is motion of a vehicle, oscillation of a pendulum. Okay, so don't get confused if they ask you to write a note on accelerated motion, because non-uniform motion is also called as accelerated motion. Okay. After this, we discussed on this activity 8.3 as well. So I want you all to please go through it. After this activity, we discussed on measuring the rate of motion. So I want you all to please be quick through it, everyone. I hope every one of you are going through the slide. After this, here we have the formula for calculating the average speed. So I want you to please go through it as well. Then after this, I guess we had an example as well. This example shows you the information, the exact information, how can you calculate the average speed, right? So I want you all to please be quick with it as well. After this, we discussed on speed with direction. So I want you all to please go through it as well. I hope you all are going through this slide properly, because here we have the formula for calculating the average velocity as well. So make sure you're going through them properly. After this, we discussed on this activity 8.4 again. So I want you all to please go through it as well. Then after this activity, we even discussed an activity with respect to like thundering and lightning. So I hope you will be able to explain the observation and conclusion for the same. After this, after discussing activity 8.5, we have studied the example 8.2, of how to calculate the average speed of car in both units, like in kilometer per hour and meter per second both, right? After this, we even had one more example over here where we calculated the average speed, right? So I just want each one of you to please go through this as well. But see, here we have the most important part, that how are you going to convert kilometer per like, okay, here over here in this example we had it how to convert kilometer per hour to meter per second. Okay, so make sure you're going through that. That is the reason I'm like showing you the example, and you have to make sure you know it. After this, we discussed on rate of change of velocity. So I want each one of you to please go through it properly. You should be knowing the cases, like if the velocity is uniform, it is non-uniform, what are the factors which are going to affect it and everything. Okay. After this, we discussed on acceleration, so please go through it again properly. Then we had activity 8.6. Now here you have to answer all the questions that they have asked you, okay? And you have to do it with yourself, be true to yourself, okay? After this activity, we discussed on like example 8.4 as well, where we have calculated the acceleration of bicycle in both the cases which have been given. Like starting from a stationary position, Rahul paddles his bicycle to attain a velocity of 6 meter per second in 30 seconds. Okay, this is one of the case. Then he applies the brake such that the velocity of the bicycle comes down to 4 meter per second in the next 5 seconds. Okay, so for that we have the solution given. So I want you all to please go through the example properly because this is very important. It's going to help you further in solving the sums. After this, we discussed on the graphical representation of motion. So I just want you all to please go through this slide properly and quickly. I hope everyone is going through it. After this, we discussed on the distance time graph as well. And I want you all to please go through it and even go through the graph that has been shown along with the proper reading. Okay. After this distance time graph, we have this table which has been given along with time in seconds and distance in meter. And on the basis of the information provided in this table, we have drawn a graph over here, and this indicates a non-uniform graph, right? So distance time graph for a car moving with a non-uniform speed will not be linear graph, whereas for a uniform speed it's going to be a linear graph. Okay. After this, we even discussed on velocity time graph. So here we have two graphs, that is for uniform motion and the other one is for non-uniform motion, right? So I want you all to please go through it. Then we discussed on this table 8.3 that we had, where we have the time velocity of the car which has been given in meter per second and kilometer per hour. So I just want you all to please go through this as well. So here we have more information on the table that has been provided, and I want you all to please go through it this as well. After this, we discussed on, like, this is the graph that will be made if you follow the same like table, the instructions given in the table, and this is what the graph will look like. Okay. Then after this, we even discussed on this velocity time graph of an object in a in a non-uniform accelerated motion. After this, we even discussed on activity 8.7 and 8.8, right? So I want you all to be please quick with it. Then we discussed on this equation of motion by graphical method. So I want you all to please go through it as well. Now we will be discussing on all the equations one by one. So see, the first equation that we have is equation for velocity time relation. So consider the velocity time graph of an object that moves under uniform acceleration. Okay, how it's moving? It's moving under uniform acceleration, and that has been shown in figure 8.8. Okay, but over here the acceleration is like u is equal to 0, distance is 0. Okay, so from this graph, now you have to look at the graph 8.8. From this graph, you can see that the initial velocity of the object u, that is at point A, it increases to v at point B. Okay, u is at point A, v is at point B, and that it covers in time t. Okay, so the velocity is changing at a uniform rate, right? It's a linear graph that we have got, so we can say that it's moving at a uniform rate. Okay, so in figure 8.8, perpendicular line BC and BE, can you see BC and BE that has been drawn from point B on time and velocity axis respectively, so that the initial velocity is represented by OA. Can you see OA in the graph? So that becomes our initial velocity, and the final velocity is represented by B and C. So initial velocity is OA, final velocity is BC, and the time interval is T, and that is represented by OC. OC is the time interval, OA is the initial velocity, and BC is the final velocity. Okay, so here we can say that BD is equal to BC minus CD, right? BD is equal to BC minus CD, and that indicates us the change in velocity in time t. Okay, now what we need to do is we need to draw AD parallel to OC. I'll show you. What are we doing? Can you see this AD? We have to draw this line, and it should be as such that it is getting parallel to OC. Okay, so what we will get? We will get BC as, here we have B and C. BC will be equal to BD plus DC, and that will be equal to BD plus OA, because DC and OA are equal, right? So instead of writing DC, we can write OA, because OA is the initial velocity. So we will substitute BC as V and OA as U. It means V is the final velocity, U is the initial velocity. So final velocity becomes equal to BD plus initial velocity. Okay, so BD is equal to final velocity minus initial velocity. So this is how we get this formula. BD is equal to final velocity minus initial velocity. So from the velocity time graph, acceleration of the object is given by, acceleration we represent it as A. So A will be equal to change in velocity upon time taken. Change in velocity is BD upon AD, and we know we can write AD as OC. Sorry, right? Because all the four sides of this are equal. So AD can be written as OC and CD can be written as OA. Right? So here we have. So we will substitute OC as time t. So we get A is equal to BD upon t through this. BD will remain the same. We are substituting OC as t, and we get the acceleration as BD upon t. So BD is equal to AT, acceleration into total time. Okay, now using equation 8.8, BD is equal to V minus U. Another equation as BD is equal to A2. Using both the equation, we get the formula as V is equal to U plus AT. That is, final velocity is equal to initial velocity plus acceleration into time. So I hope every one of you are clear how we get this. Yeah, because it's very important for you to understand this thing. Okay, now I want you all to just take a note of it quickly. Okay, I hope every one of you are clear with it. After this, we have equation for position time relation. So see, let us consider that object has traveled a distance s in time t under uniform acceleration. What are we considering? That the object has traveled distance s in time t under uniform acceleration a. So, in figure 8.8, the distance traveled by the object is obtained by the area enclosed within OABC. How are we going to enclose that area as OABC? Can you see this area? Just a second, I'll show you. Okay, so we have OAB over here and C over here. So the area is equal to this. Okay, and OABC under the velocity time graph AB and distance s traveled by the object is given as OABC, which is a trapezium again, right? So is equal to area of rectangle OACD, OADC plus area of triangle ABD. ठीक है? So we can calculate it by the trapezium formula, OA into OC. Now find out where is OA. Here we have OA. OA into OC is equal to half AD into BD. Got the formula 8.10. What the formula states, OA into OC is equal to half AD into BD. So we are going to substitute U as OA and OC as AD, which is going to be equal to T, and BD is acceleration into time. So you get the formula over here as S is equal to UT plus half AT square. It's just that you need to like go through the graph that has been given very properly. Otherwise it will become difficult for you. Okay. I hope everyone is doing it. Then we have the third equation as equation for position time graph, like position velocity relation. So see, from the velocity time graph that has been shown in figure 8.8, this one. Okay, this is figure 8.8. The distance as traveled by the object in time t, moving under uniform acceleration a, is given by the area enclosed within the trapezium. Okay, and the trapezium is OABC under the graph. Can you see OABC? Okay, so using that, we know distance is equal to area of trapezium OABC will be equal to OA plus BC into OC divided by 2, and we are going to substitute OA as U, because U is the in initial velocity, BC is the final velocity, and OC is the time taken for that. So you have to draw the graph beside and you have to check it. Okay, so according to that, we get the formula as S is equal to U plus V into T upon 2. It's just that we have substituted U, V, like we have allotted it as initial and final velocity and all, right? So from the velocity time relation, we get T is equal to V minus U upon A through equation 8.6, and here we are going to use equation 8.11 and 8.12, and using that we get the formula as S is equal to V plus U multiplied by V minus U upon 2A. Okay, so you won't understand it unless and until you will you will have the graph beside, drawn beside, and all the formulas. Like if you remember, here we have 8.8, 8.9 that has been mentioned, so you have to write and keep it with you. Okay, so just write this as well and then we'll proceed further, everyone. I hope every one of you are writing it in your book. So now, like, I'm going to continue with this example 8.5 in the next class. So along with this example 8.5, we have one more example over here as 8.6, which we'll discuss. Then we have one more example 8.7, and after that we will be discussing on uniform circular motion. Okay. After discussing on uniform circular motion, we will be discussing on this activity 8.9, which has been given over here, and then we have the summary discussion for the whole lesson motion. Okay, so we'll be doing that as well, and after that we have like 10 exercise questions to discuss. I'm going to show you the slides one by one, and I want each one of you to please go through it, all the exercise questions, because you are the one who need to answer them all later, right? So please go through the questions given. So this is how we will be ending up with the whole lesson of motion, and next part can be the last part for the lesson as well. So make sure you keep on revising everything that we have discussed, and I hope you are understanding it as well. Now for the last equation, I want you all to please draw the graph for that, and along with that make sure you write all the like that we have labeled as 8.8, 8.9, all the formulas together, and then you do it on yourself. Okay, do it by yourself and you will understand it better. Okay, so I'll end this part over here, and I want each one of you to revise everything that we studied so far. Thank you everyone.